Hello, this is Anshul Gupta. So today we are going to learn about trigonometry. By the end of this chapter, we will be able to know about trigonometric ratios, identities and its various applications. So I hope you are excited. Let's start. For trigonometry. Trigonometry means measurement of triangles. It is formed from two Greek words, that is trigonon and metron. Trigonon means triangle and metron means measure. So trigonometry means measurement of triangles, especially the right angled ones. So let us look at a right angle triangle and try to understand various terms. First of all, this is a right angle triangle, right angled at C. So the side opposite to this angle is known as hypotenuse. Now we can see two acute angles here, that is angle A and angle B. According to what is given in the question, we have to consider one particular angle. Here we are considering B. So the side opposite to the angle we need to consider is known as perpendicular, and the side containing the angle we need to consider and the right angle is known as base. In this case, AB is hypotenuse, BC is base and AC is perpendicular. So our next topic is trigonometric ratios. Now what is trigonometric ratios? Trigonometric ratios are nothing but the relation between various sides and various angles of a right angled triangle. We have six main ratios, that is sine theta, cosine theta, which is abbreviated as cos theta, tangent theta or tan theta, cosecant theta or cosec theta, secant theta or sec theta, and last one cotangent theta or cot theta. Now their formulas is sine theta is equal to perpendicular upon hypotenuse. It means this side upon this side. Cos theta is equal to base upon hypotenuse. It means this side upon this side. And tan theta is perpendicular upon base. It means this side upon this side. Now once we find out values of sine theta, cos theta and tan theta, we can easily find out values of cosec theta, sec theta and cot theta by just taking reciprocal of them. So cosec theta is reciprocal of sine theta, sec theta is reciprocal of cos theta and cot theta is reciprocal of tan theta. Now some students might find it difficult to learn these formulas, but I have a solution for this. I have a trick. So we can learn it by PBP HHB, which is a mnemonic for Pandit Badri Prasad, Hindustan Hara Bhara. So this line is for numerator and this line is for denominator. Remember, you should always learn formulas by heart, but this mnemonic can help you for some time. So now let us see an example to boost our learning. So we take a triangle here whose hypotenuse is 5 cm, its base is 4 cm and its height is 3 cm. So we know sine theta is equal to perpendicular upon hypotenuse, so 3 upon 5. Now cos theta is equal to base upon hypotenuse, so it's 4 upon 5, and tan theta is equal to perpendicular upon base, so it's 3 upon 4. Now for finding cosec theta, sec theta and cot theta, we have to take their reciprocals respectively. I hope you understand this. Now let us see values of some trigonometric ratios at various angles. So we have mainly 5 standard angles at which we have to learn trigonometric ratios values. So these are mainly 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. And the ratios, trigonometric ratios we are considering are sine theta, cos theta, tan theta, cosec theta, sec theta and cot theta. Now value of sine theta at 0 degree is 0, at 30 degree is half, At 45 degrees 1 by root 2. At 60 degrees root 3 by 2. And at 90 degrees 1. Now, for finding values of cos theta, we have an easy way. We just need to start reading values of sin theta from the end. See, the end term of sin theta is 1 and the starting term of cos theta is 1. So we just need to start reading it from end and we will get result for cos theta. Now for finding out values of tan theta, we just have to divide sin theta by cos theta. So 0 by 1 is equal to 0. 1 by 2 upon root 3 by 2 is equal to 1 by root 3. So we can easily find out values of various trigonometric ratios at different angles using this method. And we know that for cosec theta we just have to take reciprocal of sin theta. For sec theta we have to take reciprocal of cosec theta, and for cot theta we have to take reciprocal of tan theta. Now if anyone find it difficult to remember the values of sin theta, and we know that once we know the values of sin theta, we can easily find out values of cos theta and tan theta and all the other trigonometric ratios. So the trick is, for sin theta, write counting from 0 to 4. So see 0, 1, 2, 3, 4. Now put them under a root and after that divide them by 2. So see, root 0 by 2 is equal to 0. Root 1 by 2 is equal to half. Root 2 by 2 is equal to 1 by root 2. Root 3 by 2 is equal to root 3 by 2. And root 4 by 2, that is 2 by 2, is equal to 1. So you must be wondering where we use all this trigonometry. So let us see a real life application so you can connect with it. Let us consider this a wall. Now we take a ladder which is leaning against the wall and making a 30-degree angle with the ground. Now do you think we can find the height of the wall without actually climbing it? Yes, we can. This is where trigonometry plays a huge role. So for solving it, first we have to find the value of sin 30 degree. We know sin 30 degree is equal to perpendicular upon hypotenuse. Here perpendicular is the height of the wall and hypotenuse is the length of the ladder, which is 10 meter. And by the previous table, we know sin 30 is equal to half. So by cross multiplying this, we can find the value of height. So this is how we use trigonometry in real life. We use it for various purposes like finding out distances and heights of buildings. So it's very useful. So far we have learnt about various trigonometric ratios like sin theta, cos theta, tan theta and many more. Now we will learn about trigonometric identities, which are nothing but relations between various trigonometric ratios. So our first and most important trigonometric identity is sin square theta plus cos square theta is equal to 1. Next one is 1 plus tan square theta is equal to sec square theta. Third one is 1 plus cot square theta is equal to cosec square theta. Now you all must be wondering why these identities are truth. So let us prove this. First of all, you know about Pythagoras theorem, that is square of perpendicular plus square of base is equal to square of hypotenuse. Or in short, we can say p square plus b square is equal to h square. So we will use this formula to prove our first identity, that is sin square theta plus cos square theta is equal to 1. So first of all, let us write Pythagoras theorem. P square plus b square is equal to h square. Now we need to divide h square on both sides. When we divide it, we will notice we got p by h whole square, that is sin square theta, plus b square upon h square, that is cos square theta, and h square upon h square, that is 1. So this is how we got our first identity, that is sine square theta plus cos square theta is equal to 1. Isn't this wonderful? Now let us move to our next identity, that is 1 plus tan square theta is equal to sec square theta. For this again, first of all let's write Pythagoras theorem, that is p square plus b square is equal to h square. Now divide both sides by b square. So here we get p square by b square plus b square by b square is equal to h square by b square. And we know p by b is equal to tan theta. So we get here tan square theta. B square by b square is equal to 1 and h square by b square is equal to sec square theta. So we have proved our second identity. Now let's move to third one. So our third identity is 1 plus cot square theta is equal to cosec square theta. So for its proof, let's take again Pythagoras theorem, that is p square plus b square is equal to h square. Divide both sides by p square. So we get p square by p square, that is 1, b square by p square, that is cot square theta, and h square by p square, that is cosec square theta. So how do you feel about this? Aren't this easy? Now let us see some examples on trigonometric identities so we can strengthen our concepts. First example is, we have to find the value of 1 plus tan square theta upon 1 plus cot square theta. Now from the identities we have read previously, we know 1 plus tan square theta is equal to sec square theta and 1 plus cot square theta is equal to cosec square theta. So this expression will convert into sec square theta upon cosec square theta. Now we know sec square theta is equal to 1 by cos square theta and cosec square theta is equal to 1 by sine square theta. This expression will become tan square theta. So we have simplified this expression to tan square theta. Now let's take a different example. In this example, we have been given the value of sine theta, that is 3 by 5, and we have to find values of cos theta and tan theta. Let us first find the value of cos theta. Now we know the identity sine square theta plus cos square theta is equal to 1. We have to put the value of sine theta which is given and we have to solve this equation. On solving, we will get the result cos square theta is equal to 16 by 25, which implies cos theta is equal to 4 by 5. Now let us move to the second part of the question, that is finding tan theta. So tan theta is equal to sine theta upon cos theta. We are provided with the value of sine theta and we have just find out the value of cos theta. So what we have to do is just divide these two and we'll get the value of tan theta. I hope you understand all this. So this is for today's class. Today we have learned a lot of things like about basics of trigonometry, trigonometric ratios and trigonometric identities. So I hope you guys enjoyed this lecture and I wish you all the best for your future.